All right, ladies and gentlemen, we are going to try this for the 7th time to see if we can get this to work. So I am sorry I'm hoarse, but there you have it. So we're going to try to do, again, 8.1, the basic integration rules. So we've done a lot of work with integration, but we're going to go back and review kind of some simple, some unique cases, and then show you some tricks to manage those unique cases. So we're going to start by comparing three very similar integrals. The first one is 4 over x squared plus 9 dx. The second one, we're going to change the numerator, and it's going to be 4x over x squared plus 9 dx. And then the third one, we're going to change the numerator again over x squared plus 9 dx. So what I'd like to do, change my little thingy a little bit, is go through each one and talk about why they're unique. So if I start this one, 4 over x squared plus 9 dx, I could let u equal the x squared plus 9. Then my du is going to be 2x dx. And that's going to be a little bit problematic. So let me see if I can get this kind of going the right way. There we go. I don't like that one. But if you go back and remember, if you see an integral that is 1 over a squared plus u squared du, get my mouse out of the way so it doesn't screw stuff up, then this is equal to 1 over a arc tangent of u over a plus c. So that's what we're going to do with this one. So I'm going to rewrite it a little bit and make it the integral of 4 over 9 plus x squared dx, which is 4 over 3 squared plus x squared. Oops, I need my dx. So now it's very similar to what we've already done. Okay, so all I need to do is just substitute into my formula. So this is going to equal, I'm going to pull the 4 out front, okay, and then I'm going to have 1 over 3 arc tangent of x over 3, and then there's my plus c. I could distribute one more time to make it look a little pretty, and I would have 4/3 arc tangent of x over 3 plus c. And that one's done. Alrighty. So now let's look at b. Okay, I got some weird shadows going on. See if I can get that better. Alright, here's b. And notice that the only thing that's different is my numerator has changed a little bit. So let's go back and look at the work that we kind of took off already. So in this, we started with letting u equal x squared plus 9, and then my du was 2x dx. That's almost what I have. So I am going to pull that 4 out front, and I'm going to have x over x squared plus 9 dx. So I'm going to let u equal the x squared plus 9. du is 2x dx. So I need a 2 on the inside, so I'm going to introduce a 2 on the outside, and then I end up with 1 over u du. Lots of u. Doesn't look like it, but it is. So this is going to be 2 natural log of u, which was x squared plus 9, and then plus c. And then that one's done. Alrighty. C. So this integral is still yet again a wee bit different, x squared plus 9 dx. And in this one, what I want you to notice is that the degree is the same, top to bottom. So I'm going to start by doing some long division. So I'm going to divide x squared plus 9 into my 4x squared, and then technically 0x and 0. So 4x squared divided by x squared is 4, multiply through, plus 36, change the signs, there we go, okay, and so I get a negative 36, which remember is my remainder. So I can rewrite my integral as 4x squared over, and then I'm, oops, sorry, brain and mouth aren't working, well let me try again, it's going to be 4 minus 36 over the x squared plus 9 dx. A little punchy after doing this one so many times. Alright, so then when I do my integrals, I'm going to split them up, minus, and I'm going to pull that 36 out front, 1 over x squared plus 9 dx, okay? And this one we've actually kind of managed already, so it's going to be fairly simple to substitute things in. And then I'm going to have 36. This is 3 squared, remember, so this is 3 squared plus x squared. So this is times 1/3 arctangent of x over 3 plus c. Simplify it a little bit more, and I get 4x minus 12 arctangent x over 3 plus c. And this one's done. Woohoo! Alrighty, so now let's move on to our next example, different problem. And we're just learning some different tricks each time. And then we'll kind of make a list of those tricks at the end when we're done. We want to evaluate the integral from 0 to 1 of x plus 3 over 4 minus x squared dx. So there is a handy dandy little trick that says I can separate the numerator. Can't do the denominator, but you can the numerator. So that's what I'm going to do. So I'm going to rewrite this as the integral from 0 to 1 of x over the square root of 4 minus x squared dx, and then plus the integral from 0 to 1 of 3 over, and then 4 minus x squared dx. Okay? So since I have an x on the top on this one, I'm going to let u equal my things on the bottom. So I'm going to do 4 minus x squared, so my du is a negative 2x dx. Okay? So I want to introduce a negative 2 on the inside. So I'm going to introduce a negative 1/2 on the outside, 0 to 1. And this becomes my negative 2x dx is my du. And then it's going to be over the square root of u. On this one, I'm going to pull the 3 out front and then rewrite this as the square root of 2 squared minus x squared dx. And notice that in this one, there's no variable in the top. And if you'll remember, this is going to look very similar to my arc sine. So when I do my math, I'm going to get a negative 1/2 integral from 0 to 1 of u to the negative 1/2 du. And then the integral for this guy, and then 1 over 2 squared minus x squared. So my a is going to be 2 and my u is x. If I finish my math, I'm going to get a negative 1/2. U to the negative 1/2 and add 1 is u to the 2. So then I'm going to divide by. So there's my 2. I'm sorry, I mean it's to the positive 1/2. Whew. U to the positive 1/2. And this guy's going to be integrated from 0 to 1. And then here's this guy. And this becomes the arc sine of x over 2. And this guy's evaluated from 0 to 1. So I'm just going to combine those. The 2's cancel, so I have a negative square root of u plus 3 arc sine of x over 2. And I'm going to evaluate the whole thing from 0 to 1. My u was, this is the negative 4 minus x squared. So now I can start evaluating. So I'm going to get a negative and then 4 minus 1 plus 3 arc sine of a half minus a minus 4 minus 0 squared is 0 plus 3 arc sine of 0, because 0 divided by 2 is 0. So clean things up a little bit. So we have a negative radical 3 plus 3. So then if I think about where sine is a half, this is pi over 6 plus 3 times pi over 6 plus the square root of 4 and then plus 3. Sine is 0 when the angle is 0, so this is times 0, so he goes away. Clean it up just a little bit more, and this is a negative radical 3 plus pi over 2 plus 2, and there's my answer. Now if I wanted to get a decimal, I could, and that would be equal to about 1.839. So there we go. Nice, handy dandy little trick. All right, so my next example, if I can move my paper up a little bit, is going to be a slightly different case. I'm just doing lots of different possibilities. So if I had x squared over 16 minus x to the 6 dx. Well, if I think about this one, here's the x squared. I could rewrite this as 4 squared minus x to the third squared, then dx. Okay, so I have an a squared minus a u squared. So I'm going to let u equal x to the third. So du is 3x squared dx. Okay, so then I'm going to introduce a 3 on the top. So I'm going to introduce a third outside. So my integral is going to become a third of du over 4 squared minus u squared. And again, this is my sine one that I've done already. So then that means this is going to be a third times the arc sine of u x cubed, remember there's my u, over a, which is 4, and then plus c. So it's done. So that one was actually fairly straightforward. All right. Our next one is kind of fun because it is a disguised, G-U-I-S-E-D, form of the log rule, but you wouldn't know that when you first get started. So here's our problem. We're going to find the integral of 1 over 1 plus e to the x dx. So if I let my u equal 1 plus e to the x, and then I do my du, I get e to the x dx. I don't have an e to the x in the top, but I could introduce it. So what if I rewrote my integral as 1 plus e to the x minus e to the x, net effect is 0, so I haven't changed my integral, divided by 1 plus e to the x dx. So notice that these two guys are kind of the same, and then these two guys are going to fit this. That's pretty polite, so I'm going to rewrite my integral. So it's going to become the integral of 1 plus e to the x over 1 plus e to the x minus the integral of e to the x over 1 plus e to the x dx. Well, this guy is 1, so this becomes the integral of 1 dx. And then this situation right here is this situation. So then I'm going to have minus the integral of 1 over u du. So this is pretty easy. So this is going to become x minus the natural log of 1 plus e to the x plus c. And we're done. So that's kind of cool. This is a pretty unique situation where I add and subtract the same value. And as you do more of these, that will become a little bit more obvious. All right. Our next one is also one that's in disguised. And I'll show you this one because I think this one is kind of fun. So if I do the integral of the cotangent of x times the natural log of the sine of x dx. And you're going, oh no. So let's just start and let u equal the cotangent of x. Then my du is a negative cosecant squared x dx. Well, that's a pisser because that doesn't work, so we don't like that one. So let's switch and let u equal the natural log of the sine of x. Well, du is going to be 1 over the sine of x times the derivative of the inside, which is cosine of x dx. Well, if I write that a little bit nicer, this is the cosine of x over the sine of x dx, and lo and behold, that is the cotangent of x dx. Well, that's cool. So what my integral actually ended up becoming was the integral of u du, which is u squared over 2. Substitute everything back in, so this is the natural log times the sine of x, quantity squared, over 2 plus c, ta-da, done. So remember, if it doesn't work when you choose your first u, punt, and then try it again and see if it works. So that was actually a nice, cool little trick. Alrighty. So the next one that I want to do for you is also kind of simple, but it requires that you remember some of your trig identities. So let's say we're told to find the integral of tangent squared of 2x dx. We really don't have an integral, at least in the scope of this course, for tangent squared, but I could use my trig identities and rewrite tangent squared. So that's what I'm going to do. So I'm going to rewrite it as secant squared of 2x minus 1. There's my little brackets dx. Well, now I'm going to split that guy up, so this becomes secant squared of 2x dx minus the integral of 1 dx. Well, that guy's a piece of cake. So this one, I'm going to let u equal 2x, du is 2 dx. So I just need to introduce the half. So this is going to be 1/2 secant squared u du minus x, and then I'm going to stick my plus c in there. Well, I know that the integral of secant squared is the tangent of x, so this is going to be 1/2 tangent. My u was 2x minus x plus c, and I'm done. All right, so now what I'd like to do is kind of compile all of these helpful hints. So here are your helpful hints for your work with integrals. Alrighty, so number one, the first thing that we're going to do is we are going to expand the numerator. Alright, and so that might be if you're given a binomial squared. I'm going to do an example of most of these. So if I have 1 plus e to the x quantity squared, I could square the first term, multiply the guts together, and double it, square the last term. And then I could integrate it. All right, your second helpful hint would be to separate the numerator. So an example might be 1 plus x over x squared plus 1. And I could separate that to be 1 over x squared plus 1 plus x over x squared plus 1. And then I could integrate that. Third hint would be to do completing the square. And that's not one we typically tend to think about quite as much, but it is pretty helpful when we remember to do that. So let's say I was given 1 over 2x minus x squared. So the first thing that I would do is factor out a -1 and then rewrite it a little bit. Well, that's a completing the square, so I'm going to rewrite it, and then I'm going to have x squared minus 2x, leave some space. Half of 2 is 1, squared is 1, that was hard math. Distribute the -1, so that means I have to add 1. Oops, that one went off the page a wee bit. That's a 1, not a parentheses. So then this becomes 1 over negative, and then I have x squared minus 2x plus 1 plus 1. This guy factors to be x minus 1 squared. So then I could rewrite it as the square root of 1 minus x minus 1 squared. And then I have a squared minus u squared. And I could do some math on that one. All right, hint number 4 is I want to divide improper rational functions. And we've already done one of these, so I'm actually not going to do the long division for you, but I'll just remind you. So if you were given something like x squared over x squared plus 1, and the key to look for is if your numerator and denominator have the same degree, or if the degree in the top is higher. And I'm not going to do the division, but if you did, you could rewrite this expression as 1 over x squared plus 1. So this is using your long division. Depending on the situation, maybe you could do synthetic. But remember that this is your remainder, and we always write remainders over the divisor. This guy is your quotient. All right, hint number 5. I'm going to add and subtract because the net effect has to be 0. Terms in the numerator. All right, an example of that would be, and this one's a little bit harder to see, I think. If I have 2x over x squared plus 2x plus 1. Okay, the bottom is a perfect trinomial, so it's going to factor very politely. So in this one, we're going to do 2x, we're going to add 2 and take away 2, because remember the net effect has to be 0. And then I have my x squared plus 2x plus 1. So then I'm going to split it up like this, and then I'm going to split it up like this. So then it's going to become 2, and I'm going to factor as I go. So there's the x plus 1. The bottom is x plus 1 quantity squared. And then here's the negative 2, and I have x plus 1 quantity squared. So then at this point, these guys would reduce, and then I could keep going and finish my integration. All right. Trick number 6 is you want to use your trig identities. All right, so an example of that we've already done, or maybe they gave you something like cotangent squared x, which we don't really have an integral for, but I could rewrite it as the cosecant squared of x minus 1, and then I could do some math. All right, your last little helpful hint, and we're going to keep our fingers crossed that the video works this time. We can multiply and divide by our Pythagorean conjugates. All right, remember the purpose of a conjugate is to get rid of a problem child. So if I had 1 over 1 plus the sine of x, I could multiply by 1 minus the sine of x over 1 minus the sine of x. And the reason that I need to do that is nothing's squared on the bottom, so it doesn't really fit the rules that we have. So then on the top I get 1 minus the sine of x. On the bottom I get 1 minus sine squared x. Well, that becomes cosine squared x. And now I can split up my numerator as 1 over cosine squared x minus the sine of x over cosine squared x. This guy is secant squared x, so then, and I could keep going if I needed to, there's more that I could do, but this just gives you a general idea of what happens as you start rewriting your expressions. Alrighty, I hope that is helpful, and we will do lots of practice with these in class. See you soon.